In this video, I'm going to show you some examples of division with fractions, and it might be a little confusing at first because some of them look exactly like what we did last week with just one minor detail. So I'm going to show you this model. So in this model, you see 3 circles, 3 holes, and they're each split into 4. So a lot of kids see this, and because of what we did last week, they say, well, this is just 1/4 times 3. The answer to 1/4 times 3 is 3/4. Does that make sense with this model? No, not at all. So you're going to have to be really careful with these because when it's not shaded, we're doing division. If you think about it like pizzas or candy bars or something like that, it's usually a little easier. If I have 3 pizzas and I divide them into fourths because my boys eat ginormous amounts of pizzas, and I split them up into fourths, then my answer is the total number of pieces I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this model shows 3 divided by 1/4 is 12. I'm going to show you another example. Sometimes they're going to be in bars like this. Pretend I drew those the same sides. That's awful. So this shows 2 holes, and then I'm dividing them into this next number is going to be your fraction. So to figure that out, you have to ask yourself, what did I split this into? Well, there's 4 pieces, so that means they're split into fourths. And if I have 2 candy bars and I split them into fourths, at the end of the day, I'm going to have 8 pieces. And 8 is your answer because that is what you have after you get done splitting them all up or cutting them up, whatever you want to say. So these are going to look really similar, but they're very, very different. I'm going to show you a couple more. So going over what we did before, I start out with how many holes? 1, 2, 3, 4. So that goes first. You're dividing them into fractional size pieces. The next number is your fraction piece, like what you're splitting it up into, the tiny pieces. So I'm splitting these up into 3 pieces, so that means they're split into 1/3. And after I get done cutting all 4 up, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 12. That's my final answer. So on these, it's going to be really easy once you get the hang of it, but just be really careful because some of these models are a little wacky. And there's one model you're going to have to put the brakes on because it does not follow any of these rules. And it's going to look something like this. So you see here, I've shaded in 1/3. And now I'm gonna add some lines. Not all models have dashed lines, but I think it's logical to show the cuts are with the dashes. So what you're starting with here is 1/3. What you're dividing it into is a number of pieces, and these are the hardest ones. To figure out the number of pieces, you have to look at how many pieces you split your 1/3 up into. So I've got 3 pieces of my 1/3. I'm doing 1/3 divided into 3 pieces. And then when you finish, your answer is usually shown in problems. Sometimes they'll put it at the top, sometimes they'll put it at the bottom. Just look for a corner piece that looks different than all the others. Sometimes there's dots on them or these little hash lines. I like these because then it looks really different. So this piece, a lot of kids will say that's 1/3. But does it make sense that 1/3 divided by 3 is the same number? No, not at all. This piece here is 1/9 of the whole model. You have to count how many pieces are in the whole model. 1, 2, 3, 4, 5, 6, 7, 8, 9. The corner piece is your answer. It's going to be 1, and then the denominator is going to be the total parts in your model. So you have to count all of them, because if we split this up and it was a Hershey bar, you would get 1/9 of the whole bar. So the answer shows the part of the part. And if you start a division problem with a fraction, you're always going to get a smaller fraction. Always. Your smaller fraction has a bigger denominator, okay? So if you end up with like 9 here or something weird, you messed up big time. Because if you divide a fraction and you start with a fraction, you have to end with a fraction. And your fraction can't be the same unless that's 1. And we would never do that. It's kind of silly. If you start with a whole number, your answer is going to be a larger whole number. Because you took something whole and you split them up into tiny pieces. You have a pile of pieces. You're always going to end up with more pieces than what you started with because you cut them all up. So make sure you're watching for this. If you start with a whole number, you end with a larger whole number. If you start with a fraction, you're going to end with a smaller fraction. And don't freak out about this one because we're going to practice it a lot this week. These are the harder ones. I just wanted to go over why these are different from the multiplication models.